In this video, we're going to look at how to align images manually when the Metashape auto-align system isn't able to work properly. So in this first image, we can see typical dense point cloud that has aligned correctly. So we have a nice model. Sure, there's some floating pixels off to the side, but they're easy to clean up. You can see that it makes a decent shape. It's clearly made a reasonable 3D representation of a rock sample. And in this case, we're looking at the base. We can see that 141 of the 141 cameras, that's the individual photographs, were aligned correctly. So in this case, everything's worked perfectly well. We don't need to do anything other than move on to the next step of building the mesh and then cleaning the model up. However, in the other two chunks we have listed, and they're both versions of the top of this sample, we can see that in this case we have 164 of 164 aligned. But if we zoom to that model and move out, you can see that it looks quite different than the previous one. We've got a huge spread of pixels, and we definitely have something that looks pretty good in here, but we've also got, if I move it around, we can see it a little better. We've also got another almost ghost-like image here. So something's gone wrong. So Metashape thinks all the images are aligned. It's done its best, and it says they're all aligned, but it obviously hasn't done it correctly. There's obviously a problem. We shouldn't have all this stuff floating out here. We shouldn't have all this floating at this side, and we shouldn't have this sort of second ghost-like, almost mirror image of the part that is correct. So this is a case where we're going to have to figure that out and go in and realign certain images. And we'll cover that in a moment. In the other chunk, we have far fewer points. This was done much more quickly, just to show the difference that the number of points you're using under the align tool makes a difference. So whereas the top half, when it had 136,000 points, so running on high quality, now we're looking at only 5,000 points on lowest quality. Metashape still thinks it aligned all the images, but with only 5,000 tie points, we get something that looks even worse still. You can see that there is something approximating the sample here, but there's another cluster of pixels off to the right, and as we move around we can see there's another cluster off in the distance. So obviously we have fewer points because we're running on low quality and we have fewer tie points, but even though Metashape thinks it's aligned, it's kind of identified almost two groups of samples. So approximately half the images are clearly not aligned correctly because it's been divided into two approximate groups of pixels. So this is another case where we're going to have to identify which images have been aligned incorrectly and then realign those. So if we go back to the base model, the one that's correct, we can turn on show cameras. And this is what it would look like if all the cameras are aligned correctly. So in this case, we have 3 rings. Each of those blue squares with a perpendicular line coming out of it represents a photograph and the direction the photograph was taken from. And in this sample, the sample was rotated 3 times with the camera at 3 different angles. So we have sort of a steep angle looking down on it, an intermediate angle, maybe 45, 50 degrees, and then a near horizontal rotation as well. So that's what it looks like when everything has worked properly. So these three nice rings. And you can click on a photograph at the bottom or on one of the blue squares, and one will highlight the other for the appropriate image. We look at one that didn't work correctly. Again, we center. Straight away you can see that it hasn't worked properly. It almost looks more like a spiral pattern. So we rotate it, we can see that the circles are kind of there. Right, we have, there's sort of the remnants. The bottom ring is pretty much complete. But the middle ring and the top ring are incomplete. And there's definitely an area in here, show it here, where they are wrong, because we never took a series of photographs that moved perpendicular to the rotation of the sample. So this group are clearly incorrect. So we can search for those guys. We can stream through here just to demonstrate. So for example, we click on a sample or on one of the photographs and you can see that it's over here. Click on this one, it's over here. Search through here. So for example, 1087 is one of the ones that's clearly incorrect. And most likely it's a sequence of images that clearly are in a linear sequence, which are going to be wrong together. So you can see 1089, 1088, 87, 86, 85, 84, etc. They're forming a nice linear sequence. They're all incorrect. So I usually like to go through each of the images, just sort of check on them to sort of get a feeling for where the problem begins. That can take a little time, but it is letting me look at the images as I go through. So for example, there we go to 1059, 1058, they are in the correct position. It's 1060, 1061, 62, and 63 that appear to be the start of the problem. Anyway, so from 1060, and we scroll a bit further down, keep hunting through here. 1089, that's 1092, then you can see the 1093 is up top again, so let's go through that one more time. 1091, 1092, 1093. You can see from the images at the bottom that they are very similar, so there should be no jump there. So we're looking at 1060 to 1092 are giving us the problems. So we can try to highlight those, hold on shift, select 1060 to 1092, and that's doing pretty well identifying that certainly group that's clearly in the wrong place. And you can see how that's dragging out these pixels towards it. And then consequently it's also pushing a series of pixels away from it. So this strange axis that pixels are stretching along is being caused in either completely or in large part by these incorrectly aligned images here. So the next thing is to go in and actually try to. One way that helps to understand what's happening in the alignment process is to use the matches tool. So if you select one of the images, I'm going to take image 1085, right click, choose view matches. It opens a window. You can see we've selected 1085 at the top in this drop down. You could select any image there. We'll stick with 1085, and then it's comparing how well it matches these other images, and they're ordered from the closest best match to the least good. So if we click on 1084, because they're sequential, it makes sense that they should match well. We can see out of the 2,444 attempted common points, 902 are valid. And they're represented by the blue lines, and then invalid are represented by the red lines. So it makes sense that 1084 and 1086 would both be very strong. 1083, 1082, 1087, because they're all very close in the sequence of photographs that were taken from 1085, it makes sense that they're all pretty good. So they're, and the number of valid ones doesn't have to be very high, it doesn't have to be a huge proportion for it to work, but obviously it decreases. If we were to compare it to something that's in a completely different part of the sequence, like 1039, we see that there's not even any good attempted matches, because those photographs basically have nothing in common with each other. So we could use this to interrogate the change at the end of our sequence of images that were incorrect, which was 1092. So we select 1092, scroll back up to the top, and we can see that for 1092, the preceding image, 1091, they're both shown here together at the end of our strange misaligned group. You can see that they have a lot of valid connections, and that makes sense because they were taken in sequential order. And similarly, you've got 1090, 1089, 1088. However, 1093, which is up here, it's making a connection between those. They're in sequential order. What's happened is there's only 33 valid points to make the tie. That's sort of showing us the essence of the problem. Look how red this is. It's because the invalid connections are much greater than the valid ones in blue. So yes, there is some validity to it, and that makes sense because they're in sequential order, but there's nowhere near enough for the automatic alignment tool to have lined them up correctly. If we change to 1093, make it the subject, we can see that it's very closely related to 1094, 1095, 1096, and then it has an attempted and not really valid connection with 1092, then goes back to being most similar to 1097, 1098, and then it's trying to get one of the bottom line again. So when you take images in a sequence, whether it's a rotation, or you've taken images in a line or maybe a raster pattern, they're obviously going to be most similar to the images taken immediately before and immediately afterwards, but that doesn't guarantee that they're going to line up correctly. To emphasize that point that images taken in a sequence will be most similar to the adjacent images, we can choose part of the sequence and just click through them in sequential order to make it look like an animation. So if we start with 1056 and run through to 1065, and that will also cross the interval where our images begin to lose the correct alignment, you can see that it looks like it's simply rotating. We're looking at a freeze frame image. So human eye telling you that all it's doing is rotating around a vertical axis and there's no change. But something has happened with the alignment tool that it hasn't captured that. And instead, it thinks that the position of the camera has changed dramatically relative to the sample, as opposed to the sample rotating only through a few tens of degrees. Now we've jumped down to the 1090 through to 1100 part of the image sequence, and that's where we have the most discrepancy. That's where we have the biggest jump between 1092 and 1093. We click through those, we can see that there's really no good explanation for that. as it just rotates quite nicely through that part of the sequence. So this is where we're going to start our realignment. So we're going to go back to 1090. We know that it lines up well with 1089, 1091, and 1092. You can also see that it's helped by this being a steep inclined image. You can see all the registration points, these colored dots that are added to the turntable. And simply all we do is hover over one of them, take this dark blue, right click, place marker, new marker, and it generates a point called point 1. You can zoom in a lot on those points. I'm partly doing this zoomed out to be a little bit faster, but I find that it really doesn't make a huge difference for most models. There's not a massive benefit to zooming right in and placing the point at the very center of one of those colored dots. So representing the position of the dot is usually good enough. So there we have point 1, and there's a couple of different ways you could do this. You could simply place point 1 on each of the blue dots. See, we right click, place marker, and now we have the choice of point 1. And we can go to number 1092, and you can see that it's attempting to locate where it thinks point 1 should be, and it's slightly off the blue dot. So you can pick it up and drag it and position it over the blue dot correctly. And then we jump to 1093, and remember it's that difference from 1093 and 1092 that's really messing up our model. And you can see that Metashape thinks point 1 should be way off here, which is clearly wrong. So you can drag that and position it in the correct place over the blue dots. It's constantly adjusting, so 1094 is not as badly positioned as 1093's was. It's still incorrect, but we can move it and adjust that. And we continue to go through this. And this is definitely an iterative process. This is not a one-click process that fixes everything. You can see that with 1099, the blue dot is almost covered up by the rotating sample. And if we go to image 11, it's only just partially visible, but that's still enough. And if we go to 1101, it's now not visible at all. So that means that we can now go back to 1090. There's point 1 in the right place where we put it. And we're now going to place point 2. I like to use the outer dots if at all possible, just because they're a little bit easier to see. So we place marker, new marker, it's automatically going to be called point 2, and we repeat the process. You can see here that Metashape is projecting a line that it calls point 2. It happens to go through the yellow dot. That's where it thinks point 2 should be. It's sort of making a prediction. We're going to confirm that prediction by placing point 2 on the yellow dot. And now it's making its own guess, and you can see that it's got point 2 in the correct place. We go from 92 to 93, and point 2 is completely wrong, so we adjust it again, put it over the yellow dots. 1094 is a pretty good estimate because Metashape's trying to work with us as we go along. And we just position those. And by making use of multiple dots around the sample, you get around the problem of points being hidden as the sample rotates. So we can get to 1101, and the yellow dot is not an issue in this case. Continue through 1102, and let's continue to 1103. Right, so that gets the yellow dot taken care of. We'll go back to 1090 where we're starting. Let's take the orange dot. New marker will automatically be number 3. There's the projection that it thinks it should go through that point, which it does. 0.3. 92 is in the right place. Again, when we move to 93, it's wrong, so we adjust it. It wasn't as wrong this time. And similarly, 94, because of the constant updating, is in pretty decent starting position, so it doesn't require much adjustment. And we can drag it through here. We're almost about to lose it behind the sample. It's in the shadow. We can just about see it still in this one. It's okay to overlap with the sample slightly. You can also just about see it in 1100 poking out. So again, you can have a go and you get to 1101. It's not visible, but it's going to appear if we continue to rotate the sample around enough. There, it's poking out now, so we can adjust 0.3. We'll go to image 1105, and it's pretty clear again. You can see if we can get to 1105, because we haven't positioned 0.2 before, we can adjust that. So we can go back to 0.4 and adjust that. Like I said, it's an iterative process. You might end up having to put down 4 to 5 points and line them up on multiple images. But the goal is obviously to try to take shortcuts and be faster than that. Let's just go back to 1090. We'll put a couple of points down on the pink dot. 0.4. It's got a pretty good estimate of where that should be. It's projected line. You can see this time there is a bit of discrepancy here, so even on 1092 we have to adjust. 1093, it's the one we've always had to adjust a lot. 1094. So having manually aligned using the points a subset of our misaligned images, we select all and go back up to workflow, click align photos and run the process again for all the images, and this is the result we get. They're all highlighted in pink because we hit Control All and selected all the images. You can see now we have 3 concentric rings, as we should do, and if we zoom in, we have a reasonable looking dense point cloud with only a few scattered pixels around those and the 4 points in sensible looking location. So we have successfully realigned the misaligned images, and it's built a good setup ready for the point cloud and for making a mesh. So we have solved the problem.